Okay, welcome to Chapter 2, and this is on linear relations and functions. We're going to talk in this chapter about graphing lines, writing equations of lines. We're going to build in some new ideas related to functions that we're going to be using throughout the course of the year. We're going to start off with just some terminology review. Section 1 of Chapter 2 is called Relations and Functions. Some of this you have seen before, however, so there's some new vocab words that are new for Algebra 2 that I want to bring up to you. Make sure you have your note sheet with you, available to take down some of these notes, as well as do some of the practice problems that I do with you and leave time for you to do on your own. Okay, so to start off with, I'm going to pose some questions to see if you remember some of the vocab words from Algebra 1 that come up again in this chapter. I'm going to ask them. Pause the video each time, take a guess of what you think the word means, and then I'll tell you the correct definition, just to see if you remember some stuff from Algebra 1. So the first one is, what is a relation? Okay, a relation is a set of ordered pairs. Now try the next one. What is a function? Again, pause the video, and then when you're ready to hear the answer, play it again. So a function is a special type of relation, and it's one in which every input value, also known as the x-coordinate, is sent to only one output value, which is the y-coordinate. All right, next question, what does domain mean? Domain is the set of all input values of a function. It's just all your x-coordinates that you're going to use in your function. So finally, if you know the last question, you'll know this one. What is range? And that's all your output values or all your y's. Okay, so these are 4 words that you should have seen in Algebra 1. I'm just recalling them for you to remind you of what they mean, because we are going to use them in this chapter. But now here comes some new words. So the new phrase, besides just talking about functions, we can describe certain functions as being what's known as one-to-one. And the definition is sort of obvious with the naming of the function. You'll see that a lot this year. Math people are very dull when it comes to coming up with names. We basically put the definition in the word. So one-to-one means every x is sent to only one y. If you remember from Algebra 1, your teacher may have stressed the fact that the y's can repeat and you can still have a function. In a one-to-one function, that's not the case, and I have examples, picture examples here. So if you look at the function that is one-to-one, the one on the left, every one of the 4 input values only gets sent to one of the numbers in the range. On the contrary, if you look here, this is a function because there's only one arrow coming from each of the 4 letters in the domain. However, h and o both get sent to the number 2. So every x is not sent to only one y in this case. So that's why this one is not one-to-one. 1x to 1y. That's why it's called one-to-one. The second new word is an onto function. Onto functions are those in which every element in your range is used. So for instance, this is an onto function on the left. Notice how every number in my range B is used. There's something pointing to it. It's not one-to-one though. Notice, it's not one-to-one. These are separate ideas. You don't have to be one-to-one to be onto and vice versa. It's not one-to-one because the h and the o both get sent to 2. Okay? Now take a look at this one. This is not onto. And the reason why it's not onto is because 8 and 1 are not used. Not everything in set B has been pointed at from set A. Okay? So one-to-one versus onto. And we're going to do a little bit of an example with that. So here's a function. It's actually just a baby function. There's 5 points, and it's on your note sheet. Let's talk about some of these things. So domain. So the domain is all the x-coordinates. So we just pull out all the 5 x-coordinates and we write them as a set. I'm going to do this in numerical order because that's the way your book does it. So -4, -3, 0, 1, and 3. Next, I'm going to look at what the range is. So same idea. I just pull out all my y-coordinates. I'm going to put them in numerical order. So I'll start from the bottom. I've got -2, 0, 1, 2, and 3. Okay? Is it a function? So to check if it's a function, we look and see, do the x-coordinates repeat? And they don't. I only have, for every point, I only have one unique x-coordinate. So yes, this is a function. Now let's talk about one-to-one. So for one-to-one, do my y-coordinates repeat? Is there a certain y-coordinate that corresponds to two different x-coordinates? And I don't see that happening here. So yes, this is one-to-one. Okay, is it onto? Is every number in my range used? Well, yes. So this is one-to-one and onto for the reasons we've talked about in our definitions. Okay? Now there's a few here that I want you to try. So I want you to ask yourself 3 questions for each of these 4 mapping diagrams. Is it a function? Is it one-to-one? Is it onto? I'll do the first one with you, and then I'll let you pause and try the second or the third, final third examples. So for number 1, is it a function? Well, I don't see a spot where there's more than one arrow coming out of any of these x values. So I'm going to say yes, this is a function. One-to-one. Okay. Do I see a y-coordinate where more than one x is pointed at it? I do. Right here at 2. There's more than one arrow, more than one x-coordinate that gets mapped to the 2. So this is not one-to-one. This is almost one-to-one is almost like the opposite of checking whether or not it's a function. Remember, for a function, we look and see if there's more than one arrow coming out of the left box, the domain box. Here we're looking to see if there's more than one arrow coming out of the range box. Okay, onto. Well, every number in the range is gotten pointed at least once, so this is an onto function. Sorry, that's sloppy. This is a yes. So yes, it's a function, but it's not a one-to-one function. However, it is an onto function. Okay? Pause the video and try the next 3 before we move on to the next piece of this video. Okay, so 2 more terms to talk about related to the domains of functions. So we have a discrete function. That's the example that we were just looking at a couple slides back, where the domain is a set of individual points. So I'm going to go back a little quickly here. This is a discrete function because there's only dots on the graph. There's a finite number of points in my domain. 5 of them to be exact for this one. Okay? The other type of function is a continuous function. That's a domain that has an infinite number of points. These are the things we're going to be using throughout the course of this year, the things that have a straight line or a smooth curved graph. They're continuous. Okay? All right, so let's look at a real-world example. So the table shows the average weight of a baby for several months during its first year of life. Graph it and determine whether or not it's a function, and is the function discrete or continuous. So, sorry, this is going to be very hard to do here on this with this pen, but I'm going to try to graph a straight line to get my x-coordinates and my y-coordinates. Okay, so I'm going to plot my points. So when x is 1, maybe I'll make each of these worth 1. So maybe we'll make the x is worth 1, but we'll make the y is worth 2, so they'll fit. So we have 1, 12.5, 2, 16, 4 is up here at 22, and so on and so forth. I'm going to run out of room in my grid, so I'm going to stop here. The more important thing, I think we all know how to graph. Let's look at the second part, whether or not this represents a function, and is the function discrete or continuous. Well, do any of the x-coordinates repeat on my table? No. So this is a function. And think about it. It makes sense that it's a function. I don't think you can be 2 different weights at the same point in your life. Okay? I know scales fluctuate, but basically you're generally the same weight. Is it discrete or is it continuous? Well, the graph is just a bunch of dots, so I think it's going to be discrete. Okay? All right, so to determine whether or not a relation is a function, we use this thing called the vertical line test. And that is right here. I took this right from your book, and it's simple. And this is kind of what we were looking at when we were doing the thing on the TI Nspire. If you can draw a whole bunch of vertical lines, and each one of them only intersects your graph once, then the graph must be a function. On the contrary, if you can draw at least one vertical line that intersects your graph 2 or more times, then it's not a function. And you definitely saw this in Algebra 1. Okay? So here's what we mean. Checking whether or not something's a function. So here's a couple pictures. To see whether or not it's a function, we just draw a whole bunch of vertical lines. And again, with the tablet that I'm using to draw, straightness is an issue, but we're going to assume they're all straight. Each one of these lines only hits my graph once. So yes, this is a function. I could draw lines till I'm blue in the face, but this is always going to hit the graph once. Okay, let's look at the second picture. Well, I actually don't have to draw any lines. Look at the y-axis. The y-axis hits the graph once, twice, 3 times. So right there I know this is not a function. Okay? And the last thing I want to talk about a little bit is function notation. This is called f of x. That's how we read this symbol. It's just another way of saying y, of talking about the y variable. Okay? So if you see something like this, f of 3. F of 3 means, what is the value of your function when we make x have a value of 3? So the math that we're about to do isn't really different. It's just the notation that we use is maybe something new to you. By the way, this f of x, like it says here at the beginning of the slide, we read this as f of x. This is not f times x. You don't know how many times when I teach this, I have students that want to tell me the first step they have to do is divide by f because we have to undo multiplication. That's not what we're going to do here, and you'll see a couple examples in a second of what I mean. So here's some functions. I want to find f of 2 for each of them. So let's look at example A. Okay? F of 2 just means anywhere I see an x on the right-hand side, I replace it with a 2. Basically, it's like evaluating expressions, which is what we did at the very beginning of the year. The only difference is now I'm using this little symbol with the f. So f of 2, right, so I square my 2 first, 4, and then I stick the negative sign in front. Order of operations is key here again, ladies. And then we add 1. F of 2 is negative 3. That's it. Okay? There's a couple more. See if you can try them. Do the same idea. Wherever you see an x, replace it with 2, and we'll go over the rest of these in class. Okay? With that, I think I've given you enough to think about. Try any of the problems that are on your sheet that we haven't talked about on the video. I'll talk about them in class when we see each other next. If you have any questions, be sure to bring that to class as well. It's mostly vocab this section, but I want to make sure we get the hang of everything before we move on to more complicated things related to functions. With that, I wish you a good evening.